Welcome back. This is the 8th video in the series, Getting to Know Cimatron NC. Today's topic is templating for success. I believe that automation by templating can truly set Cimatron users apart from users of any other CAD/CAM package. Most CNC programmers never machine the same thing twice. Every part is unique, especially in a tool room. I believe that with a bit of forward thinking, 60 to 70% of a CNC programmer's job can have some sort of automation. I agree that there's no way to template 100% of every job every time. If it were that easy, the preferred software would only have one button: Cycle Start. I believe that even for the craziest job, I may be able to template just a little bit of it. Maybe this isn't 60 to 70%, but it's a start. Even at 10%, it creates time to get an extra cup of coffee, or a double-double if you're north of the border. Today I'm going to start with an electrode. Simple enough, right? By using a standard color palette, Cimatron easily selects all of the faces of the electrode for the NC process. You may be skeptical. If you've played with templates at all, then you likely already know about short names. My favorites are MaxPZ and MinPZ for electrodes. I can use them as part of a mathematical function in the procedure parameters. This allows me to set the clearance for an electrode procedure by adding a couple inches to the MaxPZ to tell the system always start above the part. Many shops today set their Z origin at the bottom of the electrode holder. This reduces burn depth errors when compared to working from the tip of the electrode. The biggest issue with this is that the height of the electrodes are variable and the height of the holder is variable. It makes it a little harder to grab a standard template that will not overfinish and will not hit the base. There are a couple ways to handle this. All roughing procedures stop at the bottom of stock. If the stock stops just below the top of the base, then the roughing will too. The first trick I'm going to show you today is stock creation. If you're using volume mill, then it must be done. So how can we do it better? Start by creating an NC setup. This allows me to lock the posting UCS, and it gives me a folder to keep my part in stock definitions. Create the part by criteria. Choose the colors of the electrode and base. Create a fixture part and select the holder by criteria, choosing color. Create the stock by bounding box and select the faces by criteria. Choose the colors of the electrode and the base. Set the offsets 50 thousandths on XY and Z positive, and a negative 650 thousandths on Z negative. The negative value pulls the bottom of the stock box up. Create a 3-axis toolpath with a clearance of 7 inches. I'll choose roughing for the automatic electrode burning stage. This will set the offset for each procedure. Create a rough spiral procedure. Select the faces by criteria. Select the cutter. Adjust the clearance to MaxPZ plus 2. Electrode to automatic, and set no Z limits. Then calculate. Create a finish mill by limit angle. Part faces will be the burn faces and extensions. Choose a long 1/4 inch ball mill. This should machine down to the top of the base but not finish it. Create another finish mill by limit angle. The electrode base as the part faces. Grab a long 1/4 inch bullnose tool and calculate. At a glance, you'll notice the tool path stopped at the bottom of the stock for the finish mill procedure also. So far all I've done is created a tool path for a simple electrode in a very slow, tedious manner. I'll save the process as a template and close the file. Then I'll create another electrode and push it to the NC environment. I'll apply the previous template and calculate. Cimatron easily added all of the geometry to the process and created each procedure based on the defined color palette. I'll save this electrode and create a slightly larger electrode on a flat holder. I'll push it to NC and apply the same template. Again, Cimatron had no problem selecting the geometry. While this electrode is calculating, I'll go back to the design assembly and create another electrode. This time I'll manually build one with more standing ribs on a flat holder. I'm using solid burn bodies and extensions to create this electrode. To learn more about them, consider watching the video series, An Introduction to Cimatron Quick Electrode and EDM Setup. Now I'll push the electrode to NC and apply the same template. Notice this is not part of the 60% I'd mentioned that is completed. It is, however, a situation that 60% of the machining is completed automatically. This helps the programmer focus on the details required to complete the process. I'll copy forward the finished mill by limit angle and change it to a remachine cleanup. Select an 1/8 inch ball mill from my library and calculate the new procedure. Now that I've added an extra procedure, I can add it to my template library. Next time I can machine a similar electrode much faster. Thanks for watching. Join us next time for the final video in the series, Advanced 5-Axis by Harry.